I am back for 4.3 tides. I don't know if y'all can see that I'm in shorts or not. I apologize for that. These are being recorded on teacher planning day. I don't even know if you can tell. You probably can. I think you can tell from there, but forgive me for having the shorts on today. But nobody here but me. So here we go. 4.3 tides. I'm going to keep going. Number of things that we want to talk about today with this last Unit 4 lesson for tides. That rhythmic pattern. We're just defining tides here. You're not writing this down yet. But tides are just that rhythmic pattern of rising and falling sea surfaces. Go back and forth. Tides do not affect the middle of ocean basins. They are affecting the shorelines, and they do have a pronounced effect on near shore marine life. There are a lot of different organisms that depend on tides, those tides are a major part of their adaptations and their particular ability to survive in that environment. And then tides drive the circulation of bays and estuaries as well, which are breeding grounds, trigger spawning, influences the lives of lots of marine organisms, all kinds of ways. Tides are an incredibly important part of how water moves. So what causes tides? Some of you may have been familiar with this already, maybe, but tides are caused by the gravitational pull of the moon and the sun. It also has a little bit to do with the rotation of the earth, but primarily we want to focus on the moon and the sun, with the moon being the part that pulls the greatest. The sun does have some gravitational pull, but because it's so far away, we don't feel it as much. Most of the pull that's happening as far as tides are concerned are coming from the moon. Yeah, we'll keep on going. All right, so a full tidal cycle takes 24 hours and 50 minutes. So just a little bit more than a full day, a full 24-hour period. So the effect of this gravitational pull of sun and earth, so the effect of the sun is only about half as much as the moon. I mentioned already the moon's pull is greater. So the moon's pull is about twice as much as what we experience from the sun. There are a couple of different types of tides. Spring tides are when the sun and the moon are in line with each other and with the earth. So sun, moon, earth, or sun, earth, moon. There are a couple of different ways that they can align, but if all three are lined up, then that causes the greatest amount of tide. They're both pulling on the earth at the same time, so their gravitational pull is in effect together. So make sure spring tides, make sure that you've got that spring tides when all three are lined up. That's going to be opposed to neap tides, and this is when the sun and the moon are at right angles of each other. We'll show you in an image in a second, but if we've got the sun and the earth lined up, then the moon would be up here. They're at a right angle of each other. So at that point, the sun is pulling one direction, the moon is pulling the other, and really they kind of counterbalance each other a little bit, causing less of a high tide and low tide, a little bit less water movement during those neap tides. Now here's an image here, kind of walks us through it a little bit. So here you have the sun and the moon. I like to picture this kind of I imagine someone is holding a large balloon that's not inflated. And here you have the sun and the moon both pulling on that balloon together, both at the same time. It's going to really stretch that balloon out. Where here for a neap tide, you've got the moon pulling it this way, the sun pulling it this way. The shape is going to stay relatively the same because it's being pulled in two different directions, keeping its shape pretty much the same. So here, just another way that the spring tide can work. Here you've got the sun and the moon both pulling in the same direction. Here you've got the sun and the moon on opposite sides of the earth pulling it away. But really the result is the same. We end up with a spring tide either way. Tidal patterns. There are three main tidal patterns: semidiurnal, mixed semidiurnal, and diurnal. So we're going to define them a little bit here. Semidiurnal are tides that have two high and two low tides of approximately the same height each day. In a 24-hour period, two high tides, two low tides. That's semidiurnal. And then we're going to jump down. We're not going to focus on mixed. We're going to jump down here to diurnal, which is where you've got only one high tide and one low tide each day, meaning in a 24-hour period, there's only one high tide and one low tide. Anybody know what we are? Are we a semidiurnal or a diurnal? We are a semi-diurnal. If you pay attention to our tide charts, if you spend a lot of time sitting by the water, you will see that tide on Florida's coast come in and out twice each day. So two high tides, two low tides in every 24-hour period here in Florida. Just an image here of how it works. You do need to be familiar with being able to read this image. There will be one of these on the test. You see that it's a 24-hour period, and you see that you've got two high tides, two low tides within that 24-hour period, so you're going to know that that's a semi-diurnal. Or you could have this image here, where in this same 24-hour period, you're only getting one high tide and one low tide, then you would need to select diurnal. So make sure that you're familiar with how to read that chart. That is going to show up on the test. Another image here, this one will not be on the test. It just gives us a little bit of a picture of how tides occur throughout the globe. We see us here with the green along the east coast of the United States is semi-diurnal. There are a number of places where you have diurnal tides as well. A lot that goes into that is not worth spending much time talking about why that occurs. Just know that we are semi-diurnal. Know the difference between diurnal and semi-diurnal. All right, so tides vary from time to time and from place to place. This has to do with the effect of land and the seafloor and lots of other things that come into play. So we do want you to go ahead and jot that down. Tide levels. I don't think there is a place for you to be writing stuff down on the study guide, and I don't have anything in bold here. So let me walk you through this and I'll tell you what I want you to write. The highest level that a tide rises in a day is called high water, and the lowest point that a tide drops in a day is called low water. Flood tide occurs during a rising tide when water is moving toward the shore, and an ebb tide is when the water is rushing back toward the sea. So let's try to capture that main idea of the rising tide and then the ebb tide. Let's get both of those. And then the period of time between the flood and the ebb is called slack water. We don't need to write that down. We are going to write some of this down for tidal range. The tidal range is the difference in water level between high tide and low tide. So that highest point of high tide minus your low point for low tide, and that's going to give you what your range is. Basically just how far is the water moving every day based on the tides. And this actually, just minor little detail here, but it does show up on the test. So let's get this down. The Bay of Fundy in Canada has one of the highest tidal ranges in the world. And last but certainly not least, tidal bores. These are pretty spectacular in my opinion, really fascinating phenomenon that happens. This is when the leading edge of an incoming tide forms a wave when it meets the current of a river or inlet. So you have a river that's coming out to the ocean, and that current is pushing out into the water, but then you have the force of a tide coming in from the ocean, meeting that force of the river current coming out. And when the two collide, one goes over top of the other, and it causes these tidal bores. Tidal bores most commonly occur in shallow estuaries and river mouths that have very large tidal amplitude. Don't worry about the tidal amplitude part, just know where they occur. That they occur in shallow estuaries and river mouths. The world's largest tidal bore occurs in China. There are several around the world. Quite a few of them do happen to be in Asia, and those places are a couple of really interesting surfing hotspots. The waves are not necessarily huge, but they travel for a very long distance, and so surfers are able to stay on the board for a much longer amount of time than they can in other types of waves. I give you, for our last slide here, just a little image of what this can look like. There's going to be a video somewhere along the way that you'll watch that'll give you a peek at this too. So you've got the tide coming in, the river current coming out, and it creates a series of these very long waves that are traveling over a long distance of time. That you've got, as you can tell, quite a bit of surfers out there who want to take advantage of that hotspot. And we do have a little bit more to cover here. Sorry, I thought that was the end for some reason. We're gonna keep on going. So we're not writing any of this down, but I want to run through it real quick. Mud flats are a stretch of muddy land that is uncovered at low tide, but then covered at high tide. And there are entire ecosystems that revolve around this. High tide marine organisms include fiddler crabs, mollusks, worms, and then you've got low tide organisms that are primarily going to be birds who are coming in to feed on some of those things that were not able to get to safety as the water receded. And I'm leaving this one in there just for fun. Nothing that you need to write down here, but I want to mention grunions for a moment. Grunions are a really fascinating type of fish that rely on the tide for their mating season. The females ride the high tide very, very far up onto the beach, where they can dig deeper into the sand, and they lay their eggs into the sand. 2 weeks later, at the next spring tide, the water covers up the eggs, and as the water comes over the eggs, it signals to them that it's time for them to hatch, and they ride the tide back out into the sea. They're just one of many examples of how organisms interact with the tides, especially for spawning and reproduction. And I'm gonna try and see if this works. I don't know if it will or not. The last thing we'll do here, I'm going to go ahead and let you watch the grunions.
On the Pacific coast of Mexico and California, from February to September, at the highest tides of the month, there's another bizarre invasion. These are Gulf grunion, fish with a seemingly suicidal desire to breed.
Sorry about that, I accidentally hit the button. Let's try this again.
These are Gulf grunion, fish with a seemingly suicidal desire to breed out of water. For just a few minutes, the entire shoreline becomes an orgy of mating fish. It starts as the females burrow backwards, laying their eggs in the exposed sand. Their plan is to deposit them as far from the reach of aquatic predators as they can. Each wave carries in more fish, all with the same purpose in mind. Among the writhing masses, the males must find a female and fertilize her eggs before they are buried for good. He wraps his chosen partner in a slippery embrace until the couple are washed back out to sea. It will be 2 weeks before the tide reaches this height again. The eggs will then hatch and the fry return to the ocean.
Well, there you have it. That concludes our Unit 4 material.